Today's lecture will be over Chapter 2, Section 2. Objectives: Number 1, describe the components of the water system on Earth. Number 2, identify the characteristics of oceanic and continental landforms. Start up today and we're talking about the ocean and the motion of the currents. The ocean circulates through currents, waves, and tides. The currents act like rivers flowing through the ocean. The waves are swell or ridge produced by winds, and the tides are the regular rising and falling of the ocean, created by gravitational pull of the moon or the sun, and the motion of the ocean helps distribute the heat on the planet, and the winds are heated and cooled by the ocean water. So what we see here is that we're going to go ahead and we're going to draw the picture of the Earth right here. What we see is that right in through the middle is going to be the equator. Now what happens is that this is where the sun's rays are hitting. Number one, they're hitting the most, and number two, they're hitting the direct. So what we see is that this becomes a very warm area right in here. Now what happens is that if we did not have the currents and we didn't have wind, what would happen is that this would just continue to get hotter and hotter and hotter to the point that things like animals would start to die, we couldn't sustain life, and all of these areas would be really hot. This area up here then would be just too cold, and this area down here would be too cold. These of course are called the poles, and what would happen is that they would not be getting that direct sunlight and the sun's rays, and so it would continue to get colder. So what we see is that with our system is that you have winds and also ocean currents that takes that warm water and helps distribute them into the poles. Now what's nice about this is that obviously it's going to make the poles a little more warmer, and some areas to the north and to the south you're actually going to see people being able to live. But what it also does is that in this middle area right here, it cools it off. Think of it this way: if you have a cup of water and you're constantly adding warmer and warmer and warmer water, it's just going to get too hot. But if you let it cool down a little bit, eventually the entire thing cools down. And that's what we see with these oceans and the currents, is that they're going to go ahead and they're going to make it so that we see kind of it kind of levels it out. It kind of makes it so it's not too hot, not too cold. Now obviously near the equator you're going to see warmer water and warmer temperatures, but it makes it so that we can live and sustain life. Now we have the hydrologic cycle. Now I'm going to draw a picture of the hydrologic cycle. What we see is that we have a body of water, and we could go ahead and we can call that just a lake right there. What happens is that again the sun is going to basically start to it kind of starts a hydrologic cycle, because the sun's rays are going to come down and it's going to warm this water. What we see is that evaporation then starts to happen, and you start to see this water starts going into the air, and then pretty soon they're going to go ahead and they're going to form clouds. Now eventually these clouds are going to go ahead and they're going to start to move, and they might hit something like mountains. Now the cloud is going to get too heavy, and pretty soon it's going to go ahead and it's going to rain, and it rains into these mountains. Then what we see is that from the mountains we can go ahead and we might have rivers, and these rivers are going to go ahead and they're going to take it to more flat land, and this flat land then will go ahead and accumulate into a lake, and then the entire hydrologic cycle starts again. The question then is that where does a hydrologic cycle start? And the answer is it doesn't ever start, and it doesn't ever stop. It just continues to go around and around and around. A little piece of trivia right here is that the amount of water that we have right now in our world today is the exact same amount that we had 10,000 years ago, and it's the exact same amount that we're going to have 1,000 years from now. Now you might sit there and say, well, wait a minute, Mr. Beyer, we've been talking about global warming, we've been talking about how the ice caps are melting. Yes, the ice caps are melting, but they are changing form. We have the exact same amount of water, it just changes form from water to ice, clouds, things like that. So what we see is that the hydrologic cycle just basically takes that water from the atmosphere to the oceans to the earths and goes back and forth. Now we've also got lakes, rivers, and streams. Lakes hold more than 95% of the earth's fresh water. Make sure too that you understand that when rain comes down, rain is actually fresh water. So the question becomes, how does it become salt water when it goes into the ocean or things like that? And the answer is it goes into salt water. So fresh water that goes into salt water will become salt water. So when it rains and it rains into the ocean, that water that's coming down is fresh water, but when it hits the ocean, then it becomes salt water. So you have freshwater lakes like the Great Lakes are a result of glacier action. Saltwater lakes, this is going to be when an outlet to the sea is cut off. Streams and rivers carry salts into the lake. Salts build up, nowhere to go, and they just become kind of in that area. So again, this becomes kind of the way that we have this with the hydrologic cycle, is that we're going to create lakes, rivers, and also streams. Now, we also see rivers and streams carry water to and from larger bodies of water. Tributaries are smaller rivers, streams that feed into larger ones. Drainage basin then is an area drained by a river and its tributaries. We also have groundwater, and groundwater is going to be water that's held in the pores of rocks, and a water table is the level in which rock is saturated. So what we see is that water can be above the ground and it can also be underneath the ground. When it's above a ground, this is where you see lakes, rivers, streams, tributaries, drainage basins, so on and so forth. But groundwater can actually go into the ground, and you've seen this before. It might be absolutely pouring rain and you look outside and there's water all over the place, and within an hour, maybe 2 hours, you look outside and all that water is gone. Well, where did it go? It didn't go up into the sky. That would take a lot longer. That water is going to go ahead and it's going to go into the ground, and basically it gets stuck there. That's where we get groundwater. That's where we get water tables. Water table level which it's saturated is wet. So for example, if you were to dig a post, you start digging down into the ground, eventually you're going to start hitting the mud and the kind of sandy types area. That right there becomes the water table. And when we have a water table, that's where you can tap into things like wells and things like that and basically use that water. Now, you've got landforms. These are going to be naturally formed features on the Earth's surface. And then last but not least, you have a continental shelf. And the continental shelf is a seafloor from the continent's edge to the deep part of the ocean. Seafloor has ridges, valleys, canyons, plains, and mountain ranges. And the islands are formed by volcanoes, sand, coral deposits, and things of this nature. So these are the things that you're going to see on the Earth. This completes our lecture over Chapter 2, Section 2. Please complete the assessments at this time.